Servo control from a radio control receiver to the servos is done by sending each servo a PWM signal, a series of repeating pulses of variable width. Small radio control servos are connected through a standard 3-wire connection, 2 wires for a DC power supply and 1 for control, carrying the pulses. The parameters for the pulses are a minimum pulse width, a maximum pulse width, and a repetition rate. Given the rotation constraints of the servo, neutral is defined to be the position where the servo has exactly the same amount of potential mechanical rotation in the clockwise direction as it does in the counterclockwise direction. It is important to note that different servos will have different constraints on their rotation, but they all have a neutral position, and the position is always around 1.5 milliseconds. Pulse duration. The angle is determined by the width of an electrical pulse that is applied to the control wire. This is a form of pulse width modulation, however servo position is not defined by the PWM duty cycle but only by the width of the pulse. The servo expects to see a pulse every 20 milliseconds, however this can vary within a wide range that differs from servo to servo. The width of the pulse will determine how far the motor turns. For example, a 1.5 milliseconds pulse will make the motor turn to the 90-degree position. The RC-PWM used in RC servo control acts very differently from the PWM used in any other system. Most RC servos move to exactly the same position when they receive a 1.5 milliseconds pulse every 6 milliseconds as when they receive a 1.5 milliseconds pulse every 25 milliseconds. In both cases, they turn to the center position. The load time can vary over a wide range, and vary from one pulse to the next, without any effect on the position of the servo motor. With many RC servos, as long as the refresh rate is in a range of 40 Hz to 200 Hz, the exact value of the refresh rate is irrelevant. The period of 20 milliseconds comes from the days where the signal was encoded in ppm format to be sent over the air. The ppm period was around 22.5 milliseconds, and the conversion in PWM was trivial. The time of the PWM high state was the time of the ppm pulse for that servo. Most RC receivers send pulses to the RC servo at some constant frame rate, changing only the high time. However, it is possible to command an RC servo to move over its entire range with a function generator set to a constant 10% duty cycle by changing only the frequency. Force. When these servos are commanded to move, they will move to the position and hold that position. If an external force pushes against the servo while the servo is holding a position, the servo will resist from moving out of that position. The maximum amount of force the servo can exert is the torque rating of the servo. Servos will not hold their position forever though. The position pulse must be repeated to instruct the servo to stay in position. Variations. When a pulse is sent to a servo that is less than 1.5 milliseconds, the servo rotates to a position and holds its output shaft some number of degrees counterclockwise from the neutral point. When the pulse is wider than 1.5 milliseconds, the opposite occurs. The minimal width and the maximum width of pulse that will command the servo to turn to a valid position are functions of each servo. Different brands, and even different servos of the same brand, will have different maxima and minima. Generally the minimum pulse will be about 1 millisecond wide and the maximum pulse will be 2 milliseconds wide. See also, servo bandwidth, servo mechanism, PID controller, servo. References. External links, Hobby Servo Basics,